Hey, how are you, Will? Okay, let's get started. What I'm going to do the next 15 minutes, I'm going to just very quickly review the concept. And then I'm going to show you a demo about a running over segment number 3, how it looks like. Yes.
Yeah, because we were able to get a successful run for the water this morning. Oh. And then last week I also was able to run.
Let me check. Let me see.
But I can't run it.
Let me check very quickly.
I don't know. I think it's so much fun. Okay.
You said which part? Homework 2, part 1?
Yeah, so I was this morning we were trying to do it. But then when I tried running the second part.
No, it's cooled down. Okay, I just restarted. Sorry. Let me actually try to get the other one check as well. Sorry about that. Right now it's working. Okay, part 1 should be working. Let me check part 2. Part 2 is still running. Okay, let me try homework 1. Homework 1 is running. Okay, all 3 servers should be up right now. Sorry about that. Okay, any other question before I start? Okay. Thank you. So what I'm going to do today is just show you very high level about what, like a 2 slides, show you what homework 3 is about. And then I'm going to run the demo to tell you what it is. And then of course you will be, you will have a lot of questions because as I said, the concept, the scenario is pretty intense. For those of people, students never done this level of programming. And then you're going to ask me all kinds of questions. And then I'm going to, based on your question, I'm going to go in deep in certain area which bothering you the most.
Okay, that's just let you know that I think that's the most effective way for you to learn something quite complicated. All right, good. So we talk about the concept of shadow object. If the screen will show up, okay, yeah. So it basically has what we call a shadow, which represents a real object in the corner. So when you want to call a function, that one is just presented as a wrapper. It will actually locate where it is and forward it to the real object and then finish the job and then get the result back to the file. Okay. So homework 3, we make it even more complicated to make it more level. It looks like this. So we're actually distribute one person object on the third server, which we call it another. So we have 3 programs running. One is called HW3 client, one is called HW3 server. The third program, I call it HW3 another, it's another server. You can think about, for example, just example, Facebook has about 2 billion active users. And they have 4 or 5 because the newest data center they have is located in Singapore. So essentially, they distribute our data in some way with some replication. Let's not worry about replication at this moment on different server. So when you actually initiate some social interaction, it will try to find the closest one that you can actually interact. So essentially, in this example, you can imagine that there was a one person, one profile on this machine, the other profile on this machine. But then I want to do a computation that's actually involved multiple person across different servers. That's why we have HW3 server. This one is HW3 server. And this one is HW3 another. So essentially, when you try to issue the call, it will go to here about an operator equal equal. I will use that as an example. And then it will actually request further to another server to retrieve. So you can think about if you know how to do this 3 server version instead of 2 machine version, you essentially can do really complicated things. You'll realize the shadow has multiple layers. So basically you will find in this example, one shadow goes to the second server, but that server hosts a copy is still a shadow. There you actually use that shadow to point into the real copy. And you can actually go down 20 levels if you want. So essentially, it's a web of shadow that's actually connecting all the resources together. And of course, the intermediate, the server that they can change things. So this is a very challenging scenario. It's very useful, it's very realistic in today's internet. All right, so I'm going to show you a demo and then I will come back to basically go back a little bit is how do I really implement that operator equal that you're familiar with from your homework assignment number 2. And how do you actually make that concept to be really distributed and you can handle that? Okay, so let me go to my demo window. Let me make it bigger. No, not this one. Oh, this is way too small. So I want to make this. Okay, this is a program. Let's try to make it clean, of course, and then I try to do a make. But the important thing I want you to just go through each of the line, you know what's being involved. Okay. Of course, I compile a few files like transaction.cpp, core CPP person. Those are the 3 classes, essentially the same as your homework assignment number 2, but I kind of extract the core part out of that. So the core is a superclass or the base class for both person and transaction. All right, so, and then what I did, you see that here, there is a Json Rpc stub. As I mentioned, that's basically the code generator reading from that specification about how the remote procedure call should be handled. So look at this Json Rpc stub. The input to that is basically this file. This is called ecs36b underscore homework 3 JSON, which is, let me just show you that, just remind you what it is. It basically declares a bunch of functions. So if you're not familiar with JSON, it's okay. I probably should send you a very simple JSON tutorial. The syntax is either curly bracket or double quote and with column. That's pretty much the syntax. It doesn't have any keyword, but everything is those four simple: bracket, curly bracket, column, and the double quote. And with that, you can actually represent essentially every single object that you want to represent. So essentially, the bracket represent is an array, and the curly bracket represent it's an object. So in this case, you can see that the bracket is outside. That means I have an array of what? Objects. Okay, array of objects. That's basically the. By the way, I make it looks pretty by make a different line. But if you look at a real, let me just show you an example. I don't know if I showed you this before. This is essentially a Facebook post. Looks like. Let me actually see if I still have it around. I thought I kind of have it in my first lecture. Yeah, this one. This one is a real Facebook post that's actually distributed to our Facebook, whether a browser or a Facebook application. You can see that this is all JSON. And that's a bracket and double quote, which is ID, and then there's a column. That's called key value pair. So column, before column is called a key or the attribute. And after column is called the value. So it's called key value pair. So essentially within an object, that's a curly bracket. It's actually contain a set of key value pair. You can consider that as a bunch of attributes in a object-oriented class. Okay, you have let me see if I have any bracket here. Yeah, I do have a bracket. I saw that. So here I have a bracket. Over here, this basically say it has 3 comments. This is a post, say New York Times or NBC, and they publish a story. What's this one? I forgot actually this one from. Oh, this one is actually from the programming when I taught ecs36b a long time ago. At that time it was called ecs30. At that time, the student has to do the C program to parse this JSON. And that particular message has 3 comments. That's why I don't know if you saw that. This is actually the bracket here. That means it has 3 comments as an array data. See here, from here, there are 3 elements. So that's really as simple as that, as a JSON. Once you know how to do it, it's really useful for you to represent almost everything in the whole internet. So 4th thing, curly bracket is an object. Bracket is an array. Column represent key value pair. And the key is double quote, whatever that string. And the value could be double quote as a string, or it could be any kind of value. Okay, it could be any value, could be another object, could be another array. So the value part is actually you will do a lot, process a lot. Okay. Okay, let's just tell you that how JSON looks like. I'm actually just show you the JSON in a way I kind of put a lot of line into that. You can see that it's an array of objects. And the first object is called the first part, which I should probably highlight it here. This is the one single object or one element of the array that contains an array of objects. So that object has a 3 key value pair. 3 key value pair. The first key is name, the second key is the prompts, the third key is return. And inside the value of the first key, name, is a string. And that string is called get distance, double quote. And the second key value pair, the key is prompts, parameters, and inside the value is an object. Remember when you saw the curly bracket, it's an object. So it's an object with that 6 different key value pair. That's how you represent a JSON. And the third key value pair is the same thing. Return is the key. And then after colon is another curly bracket. So it's actually an object with 6 key value pair. All right, so this can go as many level of depths as you want. So it could represent a really complicated data structure, object contain object, things like that. Okay. Any question? All right. So what we have here, I'm actually talk about this one. So Json Rpc stuff using this file is actually going to generate a server, which I give the name called HW3 server, and the client I call the HW3 client. So I give a name about the class it's going to produce based on this particular specification I just showed you, represent also as JSON. So you see that we use JSON to represent information. We also use JSON to represent the communication protocol. So that's how generic JSON is in today's life, essentially. All right, and then I compile 2 other files called shadow fly and shadow person. So essentially, both my fly object and the person object, they could be a shadow object. They could be distributed anywhere. I can put this person here, I can do this fly here, something like that. And after I done this, you see I actually compile a few things. So I compile this one. This, I compile the HW3 client. So what I did, HW3 client, you can see that it includes the separate compilation. So include a lot of objects file, core.o, transaction.o, person.o, shadowfly.o, shadow person.o, and then HW3 client.o. And now this part is important. I think I did provide a make file. Looks like this in the reference implementation I give to you, but just you should know the file has. This part is really important. It actually includes a lot of library. You see this part, this line. If you look at your make file, look at how many library I included in order to make the whole thing run. The first one is Json CPP. It's the JSON for C++. That's one library. So one library provide, this is pretty standard. You don't have to do anything. It's already there, Json CPP. The second one is what we call micro HTTP. This is also standard that you just include it. You can actually make your program immediately become a web client, web server. So doing a web application using this library is really, really easy for you to do that. Okay, the next 3, okay, let me introduce the last one. The last one is called -L curl. Curl is URL, you probably know, universal resource locator. That's, for example, HTTP, // blah, blah, blah. That is called a URL. CURL is a library that you can actually program in C or C++ to directly accessing URL. So that's also very useful. So now you can write a program that you can directly access to URL with micro HTTP. Then you can do a lot of things with that. Okay, that's the library. Okay, the rest library I haven't covered. Those 3 are actually those 2 or those 3. Yeah, 3. Those 3 are actually related to Json Rpc CPP. So you can see that everything is there. It's not JSON CPP. JSON CPP is just the basic JSON. But JSON Rpc CPP, common JSON Rpc CPP server, JSON Rpc client. Those are 3 libraries to use the RPC facility within the C++. Those three, depending on what machine you're using. If you're using CSIF, it should be already installed. You don't need to do anything. So in fact, if you're not feel comfortable doing system administration installation, CSIF might be a good choice for you to start at this moment, okay? But I gave an instruction online that you can actually install yourself on either your Windows 10 or on your Windows 10 WSL or install on your Mac. When you install, don't try to compile the source. I have seen so much trouble students trying to compile the source code. In the installation side, they already have a pre-compiled library. You should just install that pre-compiled library. It saves you at least probably 2 weeks of time. Even for me, I probably spent more than a week trying to get things right because there is just so many incompatibility in the compilation. If somebody already compiled for my platform, I just use it, it works perfectly. Okay. So that's how I compile the HW3 client. And similarly, that's how I compile. If you look at this, the include files is the library, the -L. By the way, -L means minus, I think L either means a linking or a library. It actually helped me to connect that. That one is HW3 server. And then I have another one called HW3 another. So I actually generate 3 programs: client, server, another. Okay, so now I'm going to run those 3 programs. Okay, I mean by the way, when you do this, you don't have to use CSI, you don't have to use internet. I actually typically test my program on my local machine. Just on my local machine, I run 3 different terminal. I actually run it like this way. So first, I'm going to run HW3 server. Okay, so I'm running server. It involves a few things, which we will look at the source code of HW3 server to see what it does. Okay, so object created, and now I'm going to run HW3 another. Look at the order. I run the server or another first before I run the client. Okay, I'm just basically running a bunch of things, and you see that I actually create a bunch of objects. Why I'm doing this? Because some of the objects is actually created on this machine, some of the objects created on the other machine. That's why you saw those lines. Okay, now I'm coming back to this one. I'm going to do HW3 client. Okay, boom. I mean, there was a bunch of things. Immediately finished, eventually it says conflict of interest or whatever. They are equal. Those are the message I'm going to show you. But you can see that both the server and another, they basically still there and then looking at some of the information. Okay, so now I'm actually going to, let me see. Let me make my program. I'm going to first show you my client program. Okay, my client program, in fact, is quite simple. Let me go through this line by line. I have, I include both shadow fly and shadow person because I don't want to create any real object on this machine. This client is just my mobile phone. I want to create a bunch of shadows so I can actually managing the objects that actually reside on either server or another, or HW3 server, HW3 another. So let's actually take a look. The first program I have is called a shadow person. The object name I gave is SP1. And remember, I'm actually going to talk about this. Is probably you shouldn't remember because I never talked about this part before because this is related to the core object. There are 4 attributes that define the core object. That's URL, VSID, class name, and object ID. If you look at the, let me now go to core.h. So core.h is basically every object I have should have this 4. The first one is host URL. means that where it is, the network address. The second one is owner's VSID. That particular object, what's the virtual student ID, well, virtual subject ID, whatever. And then there is a class ID and object ID. They help me to identify whether this object is a class person or it's a class flock, for example. And then there's object ID within that class, which object we're talking about. So those are the four attributes in the core object. Okay, now we look at this first line. The first line essentially say, I actually create a virtual person. A virtual person create this for because I don't have anything else I need. I just need to locate where it is. So look at how I get this information. The first one is the URL. The second one is actually VSID, it's just a fake one. Okay. The third one, it is the class is a person. So that shadow person is actually represent a person there. And then the object ID is a 00005 as a string. Those are the four information. So look at what I did here. What I did here is after I done that, I actually call that method. You should only look at this part. I basically just grab that shadow person SP1. And actually I call get VSID. I did some casting. In fact, that casting is not necessary. That casting is just show how virtual function will work. But with or without casting, it should behave the same in this case. And then I'm going to call get VSID. In fact, when you get VSID, it's not the owner's VSID, it's that person's real VSID. If I did my program, just finish here. Let me actually do it here, return 0 here. Okay, you can see that I have a two line. Another one is, I'm actually, the next line I said I create another object called SP underscore another. And that one I also get four things. URL, VSID, person, and object ID. Can you compare those two lines, SP1 and SP another? What are the difference between those two lines? I mean, what's the difference between this line and this line? Yes. Different, right? So number one, ID is different. Number two, the URL is different. The URL is different. Means that those two are actually belong to two different servers. In fact, the first one, 8284, is the port number. By the way, you look at the URL, you see that there is a column says 8384. That's the port number. So port number is very important for you to actually access to a service which is not a standard. For example, I don't know if you know what's the web default port number? What? 80. The web is 80 or 8080. 8080 or 80. Those two are the default port. But you can actually arrange whatever port you want. You just need to open the port at the receiving end with a different port. Then basically you're doing some communication. Nobody else knows that you're actually doing a web. I should tell you this, but when people try to monitor the traffic, they're looking at web traffic. Guess what they're looking for? They're looking for port 80 traffic. Because with your IP packet, I can actually see after you pass the first 32-bit, not 32 byte IP header, the next 8 byte represents the source and destination port. So you look at the port, you actually know it's a web traffic or it's not web traffic, and then you basically try to sniff around or try to look at what people are looking at. If I actually can arrange any port number, you might be able to evade from those kind of people try to understand what you're doing. Okay, it's just anonymity is another big story I don't want to talk about. But I have a two server, 8384, 8385. Now let's look at the server another. You will see that why it's happened this way. So let's go to homework 3 server.cpp. If I go to main, this is main function. You see now in the main, I have a real object created. Are you familiar with this? This is actually from the homework assignment number 2. I just take that homework assignment number 2 code, put it into the server side. Every object you create, those 3 address distance, I just put it there. So essentially, I'm breaking your homework assignment number 2 into the server part and the client part. But the important thing is that you see that I'm actually using the micro HTTP library. There is a web server for me to handle. And that's actually port number 8384. So HW3 server is actually offering 8384 as the port number. So when you have whatever URL, colon 8384, this server will get it. And then I just basically create a server. You can see that when I create the server, I'm just using HTTP server, which I just defined here. So whenever I have this, and then after I create this S, I say start listening. These 3 lines essentially help you to connect a workable web server within your same computer that you can communicate using HTTP. All right, so that's how it works. So first, you actually set up your port number. The second line, you set up the server. The third one, you tell the server to start listening to any incoming requests. Okay, this is 3-line HW3 server. So let's look at HW3 another. This is actually very similar to this. It creates a bunch of objects. And then this is, again, this 3-line. In the server, now it says 8385, the port number. So essentially, they're on the same machine. So this 2 server and another, they will not conflict with each other. They both are what we call local hosts. By the way, local host, technical term in IP address is 127.0.0.1. That's always referred to your local machine, 127.0.0.1. You can replace that local host to 127.0.0.1. It should work the same. Let me just replace it. I can actually change this to like this. It should be exactly the same. So you can see that I'm also doing the same thing on the top window. Another, I set up the server and then I basically say start listening. The only difference between another and server at the networking level is because the port numbers are different. Then I can have that. Okay. All right. So I'm going through this. So what I'm going to do is that I make my client much shorter. Now I return 0 at this point. So it means that I'm going to try to ask you the first 2. Try to get the BSID printed out. And with the 0005 of the first object, and the other object is 0005555. Okay, we'll see how that works. So I'm going to make again. Okay, I only changed the client. So the server, I don't even bother to restart it. So I just run the client. Okay, so now you can see that I get to the object. The first one, I got that one. The second one, I got that one. I mean, they're the same. I want to change a little bit to make things more interesting, okay? I'm going to change HW3 another. There's something, okay, you see that? This is a Lion King, right? I'm going to change this to 9A765432. Okay, so I changed the Lion King to be a different one. Okay, and then I have to restart another. And now I'm going to run the program. Okay, it's not changed. I thought I changed. Let me check. Let me check. There's a bug, obviously. Did I? What? I thought I did. I thought I did. I compiled it. Let me check. Yeah, it's here. I actually checked the ID here. Let's see what happened. That's the excitement about computer programming, because until you run the program, you don't know what you're talking about. And usually the program is right. I'm wrong. Still the same, right? Okay, wait a minute. What did I do wrong? Let me check my client program. Maybe you can help me. I know you're. So this one is localhost 8385. That's another. With this user ID, with person, with ID 005555. And let me check my HW3 another .cpp. Don't worry, we'll get this right. No, the return zero thing is here, so I'm actually changed that. I should be okay. P1 PTR. You know what? Because the PTR might be overwritten. Hold on 1 second. Let me check my PTR. Because to be honest, this piece of code, I changed so many times in the instruction. So sometimes I messed up something I forgot. P1. This is 8385. Okay, I know what I'm going to do. Because this is get VSID, I'm going to check get VSID here. I'm going to print some result. You know what? I'm actually going to print the JSON I received. Yeah, I'm going to do that. Okay, now I'm going to do this is I'm going to, let me just do a fprintf here. I just want to make sure that it's actually executing the right code. Okay, if I have this, state has failed. Apparently it's not failed, so it's come over here, object ID has another one. It's not actually called this line because it's supposed to call has HW another call. I don't think it's actually here. I don't think it's actually calling the right function. Let me check. What did I do wrong? I want to change this to I changed this one as well. Oh, you know what? I actually, is this 83, 85? Did I do wrong? Oh, wait a minute. This one I haven't updated. This one should be localhost 83, 84. So I was actually running this with Cyrus. So I used some Cyrus address. So I might have messed up the IP address there. But let me actually try to clean it. See if that will work better this time. HW3 server. HW3 another. No, it's not actually getting the one I have. Oh, you know what? Forget it. I know exactly what's going on because I was doing some testing. I actually have already programmed server running. So I'm actually modify this. I'm running with the old machine, old process. So now I know exactly what happened. I'm going to just restart everything. Okay, now I understand. I think this time I'm going to see we're going to see different results. Yeah. Okay. Now we're getting it. Okay. Before I came here, I was testing this. So when I'm testing this, I actually create another window. I actually run the server, host another HW3 server, but I forget to kill them. So when I'm running another program, which is HW3 server, I try to get a port, it will fail. Why it will fail? Because there's already a program occupy that port. So 83, 84, 83, 85. So no matter how I change, it access to the old version of the server. So now if I actually kill them and then I restart it, now you can see I'm getting the right result. Okay. Oh, I'm glad. I'm sorry that this thing is messed up. Okay. Before I go further, any question? Yes.
Just correct me if anything I say is wrong. I'm just going to clarify that I understand how this whole thing works. So a shadow object is there, it doesn't really have any information. Or the only thing it has is where to access the object. When you try to use function from the shadow object, it converts that information to JSON and sends the real one. And then that real one parses it.
Delivered to the real object. Right. That's basically correct. Yeah, that's right. Oh, okay.
I thought it was something else.
Okay, that's a very important question, and because I think 90% of the students probably have the same concern. So, does everybody hear what Nicholas just said? Okay, no. Can you want to use the mic?
I'll just speak loud.
No, use the mic so we can record it.
Okay. So what it seems like now to me that I realize is that what a shadow object does is it just holds the information of where the real one is, and then so it doesn't have anything really. And when you activate the functions of the shadow object, it sends over a JSON with that info that it needs over to the real one, and then that real one will perform its functions, access anything else it needs to, and then send it back. But the shadow object doesn't have anything besides where the real one is. It's just sitting there. Its only function is to send information over, it seems, right?
That's correct. Thank you, Nico, and so very good explanation. I appreciate that. Any other question? So yes, in the back. I thought I did. Right, I extended for 1 week.
So it's due.
Next Friday. Not the coming Friday. Yeah, the next.
So it's
I mean, sometimes English is so confused. When I say next Friday, is this the coming Friday or the next week's Friday? I mean, yeah.
So homework 2 is gonna be due the same day as homework 3.
No, homework 3 is going to be based on our progress. Homework 3 will be even later. We'll do even later. Yeah. By the way, homework 3 compared to homework 2, homework 3 is well, homework 2 is like a piece of cake compared to homework 3. Just put it that way. Yes. I thought they did. They haven't?
And that was it.
Okay, I'll talk to them. I thought that's been taken care of. They should be doing the office hour over there. All right, I'll talk to them.
Thank you.
All right, so I still have 5 minutes. Can I move to the next level? The class until 3 o'clock, right? Yeah, this is afternoon. I remember there's always funny in the morning. I have to stop at 50. In the afternoon, I actually have 10 more minutes, but I start late, of course. All right, so I'm going to do this. I want to go over, I'm going to get rid of this return 0 so I can do more. But what I really want to do is this. There are 3 operator overloading. Compare 2-person, equal. So let's just look at one of them, okay? Just look at one of them. SP1 and SP2. And remember, where's SP1? SP1 is actually in 80 or 84. Where's SP2? Let me check. SP2, I want to make SP2. Okay, let's use SP3. SP3 is 83, 85. So let's compare SP1 and SP3. One is in one server, one is in the other server. Now, how do you actually compare 2 objects using operator equal? There are 2 different processes. So let's actually compare SP1 and SP3, which is the second line. See if they're equal. Okay, so let's. Okay, let's try to run it and then try to parse the result. Okay. Oh, there are a few things which I want to get rid of. Sorry. I want to get rid of a lot of things so you only see the most important one. I'm actually going to get rid of this 3 line as well. This is conflict of interest test. Okay, good. So essentially, it basically, okay, don't worry about this one because it's trying to access to the Cyrus. But look at the last part, this piece of code. It basically, this part is getting the result from 8384 and 8385 to compare those 2 objects. And now we're actually going to see what it looks like over here. You can see that this is actually 8384. And what 8384 is actually try to obtain the VSID from the other machine and use that VSID to go into the comparison of this operator equal. So now let's actually look at the operator equal, how it's actually working. Let me get another window here. So this is operator equal equal. It's essentially compare the VSID and the name of a two different person. All right, so that is assuming that this person is actually a real person, not a shadow. And the thing is that you can see that now I'm actually not directly using what we call access private variable to actually directly access to the VSID. What I did is I used a person dot get VSID. So remember we had that discussion that C++ is actually allowed object in the whole class accessing the private variable. But here I didn't do that. I use a person dot get VSID. Why is that? Because a person is actually, it looks like it's a person that's actually a shadow person. It's a shadow person on yet another server. So when you call a person dot get VSID, it's not actually triggering the local get VSID, but trigger remote procedure call to go to the third machine, and then from there to retrieve that, and then try to do the comparison. So you can see that this is a scenario. It could get into really complicated, or it can get interesting because it's actually trigger a different polymorphic member function based on the design of virtual function. Okay, I think I will stop here. And if you have any questions, just stay here. I will be here to answer any questions.